Welcome back, Caymans. Mr. Eicher here, coming at you with the lesson on Chapter 1, Section 6, 1-6, about solving compound inequalities and solving absolute value inequalities. So in this lesson, we'll be focusing on the absolute value part, which when you solve absolute value inequalities, you'll be using compound inequalities. So let's get started. So first, do a couple examples 8, 9, 11, and 13, and you'll do number 10 and number 12 as part of your try this. So let's see, how do you solve absolute value inequalities? And we will graph the solution on a number line. So first thing it's good to indicate is you have absolute values greater than 8. Greater than 8 means we have an OR inequality. So we would write two equations. To get rid of the absolute value bars, we'll write 2m is greater than or equal to 8, or 2m, you flip the sign and change the sign. So you flip the inequality sign and you change the 8 to a negative 8. And then you solve, we divide both sides by 2 for both of these, and we would get m is greater than or equal to 4, or m is less than or equal to negative 4. Then when we graph, it's going to be a negative 4 is over here, 4 is over here. Both are closed circles, and we have greater than or equal to 4, less than or equal to negative 4. So this would be our solution. The directions didn't say to do interval notation, but I'll throw it at you anyway. The interval notation would be negative infinity to negative 4 with a bracket, or bracket 4 comma infinity. So that would be the interval notation for the compound inequality. But the directions didn't ask for that, so I guess I'll get rid of that. Let's look at number 9. Number 9, first thing is notice we have a less than. So this is all the values that are within 21. So we're not going to be pointing out to the left and to the right, being far away from 21. But we want to be within 21 units. So the two equations we write will be 6r minus 3 is less than 21. And on the left side of that 6r minus 3, we can do negative 21 is less than that 6r minus 3. So this setup matches what we had up here, right here. So the inequalities both point to the left, and one of the b's is positive, but the other b is negative. And then you can solve the inequality. You could rewrite two equations, or to get rid of the minus 3 in the middle, you could add 3 to the middle, to the right and to the left. That would give us negative 18 is less than 6r is less than 24. And then you could divide by 6 to solve for r. So divide the left by 6, positive 6, and divide the right by 6. And that gives us negative 3 is less than r is less than 4. And this is our solution, and our number line solution would be negative 3 and a 4. They're both open circles. Whoops, that's not right. You have r is between negative 3 and 4. Now there isn't necessarily a check that you have to do like the other absolute value equations, but you could check it. Let's pick a number in the middle here. Let's pick 1, and then we could do a quick check to make sure our answer makes sense. If we put 1 into r, that would be 6 times 1 minus 3. Is this number, absolute value of 3 is 3. Is 3 less than 21? Yes, it is. So it looks like our answer works. You're not required to do that check step, but it's smart. You can always check your answer and make sure you got it right. Number 10 is for you to do, and number 12. So let's look at number 11. On number 11, we first will isolate. So we have 7x, absolute value of 7x, is less than negative 4. So subtract 4 from both sides. 0 minus 4 is negative 4. So notice we have a less than sign. So that tells us we're going to have an and, if I can spell and correctly, and then we can write our two equations. We would have 7x is less than negative 4. And then on the left side of this, we could do a less than sign and a positive 4. So solving that, we divide both sides by 7, the left, the right, and the middle. So that would be 4/7 is less than x is less than negative 4/7. So being very careful here, when we go to graph this, let's see what happens. We have this side says, we'll start with this right here. This says x has to be less than negative 4/7. Here's negative 4/7, open circle to the left. And then this side says to do x is greater than, reading that way, x is greater than 4/7. So here's 4/7. And we want greater than. Does that graph look okay to you? Well, it doesn't look okay to me because it's supposed to be an and is the intersection. So what number is in the overlap of these two arrows? Well, no number. So what's going on here? Well, if we go all the way back to this step right here, you might notice, maybe you noticed before and you're like, what's Mr. Eicher doing? You should have stopped right here. You have an absolute value that's less than a negative number. You can't have an absolute value less than a negative. So really, our solution is there is no solution. There is no number line. There is no number that would be less than negative 4 units away. Remember, absolute value is a distance. It has to be positive. So there's a big problem here with number 11.